Hello, today we are going to see what is the solution of coincident line. For this, we are going to study the part given on page number 9 of Mathematics textbook part 1, lesson number 1. On page number 9, we have given two equations, and below the two equations we have given table of that. It is given, so we have copied the same equations, given equation and table for it. And these points which satisfies this given condition, x plus 2y is equal to 4, here the values of corresponding values of xy, we have three values. If we plot it on this number line, minus 2 comma 3, x minus 2 on this vertical line, 3, this is minus 2 comma 3 point. Then 0, 2, x 0, y 2. So on this vertical line, 0 here, positive 2, y. And the third point 2 comma 1, x coordinate 2 on this line, 1, it's positive 1. So these are the 3 points for equation 1. When we have joined these points, we have got the line. Now for the second equation, we have given this table which will satisfy this given condition. When x is minus 4, y is 4. X minus 4, y is 4. This point is for the second equation. When x is 1, y is 1.5. When x is 1, y is 1.5, between 1 and 2. This is the point. And when x is 3, y is 0.5. This point is little bit I have changed from the textbook just to incorporate in this graph. When x is 3, y is 0.5. When x is 3, y is 0.5. Of course, this point satisfies this given condition. Now we can see that these 3 points already lie on this line. We have drawn this line. It means this equation of this line is not a different line, but we got its same line. Or we can say the graphs of these two equations are overlapping on each other. In mathematical language, we call such lines coincident lines. That they are not different lines, but they are one and the same. In such case, what will be the solution of this coincident lines? We can understand that each and every point on this line will satisfy the given both conditions, condition number 1 as well as condition number 2. It means equation number 1 and 2. And a line contains infinite number of points. This solution of coincident lines, we don't have one unique solution as we get it for intersecting line, the intersection point. But here we can get infinite number of solution. Therefore, what is the solution of this? Coincident lines have infinite number of solution. Which are these infinite number of solution? Each and every point on the line is solution of these both lines. Now, graphically we have seen we have coincident lines. But if we don't draw the graph, still can we find whether these lines are coincident or not? How to find? For that, without drawing graph, how can we get it? For that, what we will do, we will take the ratio of coefficients of x, coefficient of y and constants, and then we will compare it. For this, let's compare this given equation into standard form. Ax plus by is equal to c. Now value of ax means coefficient of x in first is a1 is 1, coefficient of y is b1 that is 2, and the constant is 4. So these are the values of a1, b1 and c1. We got it from equation 1. Now from equation 2, let's get the values of a2, b2 and c2. So a2 is nothing but 3, b2 is 6 and c2 is 12. Now let's take this ratios of coefficient of x, that's a1 upon a2. What is this ratio? So a1 3 and a2 is, a1 1 and a2 is 3. So it is nothing but 1 upon 3. Now what is b1 upon b2? This is the ratio of coefficient of y. b1 upon b2. It is 2 upon 6. Now they can give the reduced form. So it will become 2 1s are 2 and 2 3s are 6. And what is C1 upon C2? It is 4 upon 12. Here also we can divide it by 4. And we can get 4 ones are 4 and 4 threes are 12. So what is the reduced form of each ratio? A1 upon A2 is 1 upon 3. Or you can say here B1 upon B2 is also 1 upon 3. And C1 upon C2 is also 1 upon 3. So what did we find? We find that when the lines are coincidents, the ratio of the coefficients of x is equal to ratio of coefficients of y and ratio of constants. So we get this conclusion. Or in other way, if we want to test it whether these lines are coincident or not, we can take such ratio, and if we find all these three ratios are same, then we can say the lines are coincident. Coincident means nothing but they are overlapping on each other, and in that case their solution is infinite. Each and every point on that will satisfy this equation is going to be solution of such lines. Thank you.